I work for Network Rail as the Project Delivery Engineering Manager for Old Oak Common, so heading up all of the engineering within Old Oak Common. Do you want to introduce yourself quickly?
Yeah. Hi, I'm Rakesh Athukattu. I am the DP for the Old Oak Common rail systems aspect of it, a bit more below Chris's remit as such, as he covers both a lot of the early works and the station works as well. So I look at only the rail systems aspect of it. So thank you.
We've got a bit of a tag team from the PDY point of view. I come from a track background, Rakesh comes from an OLE background, so we're trying to cover sort of the broad spectrum of the PDY. Right, so if we flick through, I'll give an overview of what Old Oak Common is. We go click on the first one. Right, so High Speed 2, I think everybody works in the rail industry knows what High Speed 2 is, a new high speed line running north to south. You know, high speed, yes, capacity, definitely. So it runs from north, so initially from Birmingham down to London, with an intermediate stop at Old Oak Common in West London. So about 3 miles out of the centre of London. The reason for that originally is that Euston, if it has all of these trains arriving at Euston, becomes overloaded. Local transport network, the Northern Line, Victoria Line, suddenly you're at capacity, and you create a massive problem for passengers. So constructing a new station at Old Oak Common enables a transfer of passengers on the outskirts of London, sort of, onto other public transport networks around the area to enable High Speed 2 to create that capacity. Now, High Speed 2, Euston is not going to be open when High Speed 2 opens, so Old Oak Common has become more and more critical. I'm sure you've heard in the news recently where people are saying Old Oak Common is a terminus. So when High Speed 2 opens, trains from Birmingham will terminate at Old Oak Common to begin with. So that will be the terminus of High Speed 2 for a number of years. So all passengers will get off at Old Oak Common. And the station that we're building is to facilitate that as well. So making sure we've got that temporary state as well as the permanent state. Location of Old Oak Common. So I said it's in West London. It's an interchange station, so you've got High Speed 2, which is shown in blue. You've got the Great Western Main Line, which is shown in sort of purpley colour, which includes Crossrail. Okay, so that's the main purpose of the connection, but actually, there's quite a few connections in the wider area. So you've got Willesden Junction, which is sort of a 10-minute walk away. You've got a couple of Central Line stations that are about a 10-minute walk away. But then there's proposals that were developed sort of AIP level to produce 2 new overground stations just a few minutes walk away from Old Oak Common. And there's also a proposal for a new Chiltern Line, Wickham Line station to connect up to the Chilterns and give them a 2-platform terminus as well. So it's actually become a bit of a transport super hub, which links up to the wider regeneration of the area to create somewhere that is going to be one of the best connected parts of London, which helps them support, you know, people using High Speed 2 and getting to where they need to get to at the end of their journey. Go to the next slide. So, yeah, so what we're trying to create is a single station. So what you've got is subsurface. There are 6 high-speed 2 platforms. And on the conventional rail network, at ground level, there are 8 what will be Network Rail managed platforms. So it's located on the existing Old Oak Common depot site. So for those who don't know the area, you've got sort of at the moment, you've got a 4-track Great Western Main Line through here, 2 reliefs, 2 mains. To the south side, you've got the IEP depot, which is where all Class 800s are maintained, which forms a sort of hard barrier to the south for us. So that maintains all of the GWR's regional fleets. Then you had the Heathrow Express depot and the Great Western Railway depot, which maintained their HS2 fleet before. They've both now been demolished, decommissioned, and to the north of that, again, you've got Crossrail depot. So it's been railway land for over 100 years and a major depot for Great Western Railway. So in terms of London, there's this big railway space. The DfT spent a lot of money relocating and moving these depots away from here to free up space to build this station. The aim is to open into operational service 2029 to 2033. Now, that is the window of opening, and this is a lesson learned from the likes of Crossrail to not give a hard date, but to give a window of sort of earliest to latest and aim for your most likely, so that public perception of the industry isn't damaged if you don't hit that that initial date. Oh, and there's sorry, just going back, there's a nice image of the station. So the signature of this is this beautiful roof. Now, just a bit about, I guess, actually we'll come to that in a further slide. So you can also see, the urban realm here. You've got a major bus depot. Click along. So here's a sort of wireframe image of the station. Now, all of the station civils are being built by High Speed 2 directly with their contractor BBVS, Balfour BT Vinci Sistra joint venture. So WSP have done the design, and BBVS are then doing the construction of the station, both the subsurface and the surface level. Then High Speed 2 has then sort of contracted Network Rail to then deliver the rail systems part of it. So that's what we're most involved with, but because a great chunk of this becomes a Network Rail asset at the end of it, Network Rail is also interested in making sure that its requirements are met, and that it fulfills all of our needs in terms of passenger experience, asset management, etc. So you've got subsurface, you've got the tracks that you can't see below ground, and you've got this large interchange bridge, much like Reading. So if you think about Reading, that's a very similar sort of setup for what we're trying to build here. And at either end, you've then got additional means of escape bridges, but also additional passenger circulation and lift shafts at the end of each platform and in the middle. So there's a lot of capacity to move people through here, because we anticipate it being one of the busiest stations in London because of its connectivity. Click to the next one. It's just got a little bit about how it's used. So this is sort of one model of passengers. It's not so important to look at the exact numbers, but it's about where the flows are moving. And actually, the biggest flow of interchange here isn't with High Speed 2, it's Crossrail to the Great Western Main Line. So actually, once you build this station, one of its strategic benefits is for Great Western Railway passengers travelling from further west, Bath, Bristol, Wales, the southwest, etc. Rather than going to Paddington, walking around and going down the escalators to Crossrail, it's almost a cross-platform interchange. They've just got to go up across the bridge and down. And that actually, I can't remember the exact number, but it saves a significant minutes on a journey. That is a big part of the business case itself. And so in the morning, we expect most people to interchange onto Crossrail here. So in the morning peak, you see a big flow of people getting onto the up Crossrail platforms. I'm calling it Crossrail, obviously, Elizabeth Line, interchangeable. And then, High Speed 2, the main exchange is onto those Elizabeth Line Crossrail platforms as well, with a exchange onto the Great Western Main Line as well. Okay, so the big interchanges are expected to be between the conventional rail network and the metro service and High Speed 2. So this model here is catering for a 2041 PED flow. Now we're still designing the station to that level. Obviously, post-COVID, there's lots of assessments being done on what is the right sort of train service to provide for, etc. But at the moment, we're still carrying on with our original plans because the recovery midweek is still pretty decent. So we're allowing for our full trains per hour service that we were looking at pre-COVID, because the station has to stand for 100 years. Next slide. Okay, so this is just a bit more about the regeneration of the area. So I appreciate this is big overview and not sort of nuts and bolts engineering, but I think it's important to give an overview of why we're doing it. What you can see here is this massive industrial estate. So this is probably the sort of biggest, I can't remember what its name is, but it's a sort of strategic industrial site in London. So that's the sort of picture there. You've got Car Giant, if anyone knows that, it's just a massive car park. You've got depots and warehouses, and this part of London is, you would say, sort of underdeveloped, I think, historically. And part of the aspirations of this, part of its business case, is to grow the site. So if we flick to the next one, hopefully I'll go, supposed to create, some numbers: 25,000 new homes, 65,000 jobs, and apparently boost the UK economy by up to £7 billion a year. So in terms of its ability to regenerate the area, it's massive, and it's the same for high-speed 2 stations in other areas. Yes, it provides a transport link, but actually to regenerate the areas, it's got a massive boost to the local economy and the national economy. The reason I put this in is I mentioned the bus depot. Part of it is actually, it's not rail. We build some bridges that enable double-decker buses to come down here. We create a new bus depot, and actually it becomes the hub of the bus network in this part of London. So it's more than just railway infrastructure, it's public sector, public transport. We're actually influencing the much wider transport network than just rail. Next one, please. And this is a nice artistic vision of what it could look like. So at the moment, you sort of see these high rises here, these ones here, and these ones here. These don't exist. So the idea is that we create, you know, for people familiar with London, sort of a Stratford or a Canary Wharf style development, but in the west. Because you're connected to Heathrow, you're connected to the rest of the country via High Speed 2, you're connected to Crossrail, and you're just very well connected. So the idea is massive regeneration. And so the Royal Borough of Kensington and Chelsea and another local borough, I can't remember, formed a local development corporation called the Old Oak Common and Park Royal Development Corporation that has sort of planning permission rights and sets the strategic vision for this area. And they've got, these master plans to sort of develop it and create all those jobs and maximise on the benefits that creating this new station creates. Okay. Yeah, next please. Okay, so hopefully it's big enough for people to see. I thought I'd give a little overview of the layout and what we're trying to achieve. So our requirements are to enable, in the peak, 22 trains per hour on the main lines. So to achieve that, you've got your up and down main, you've got two island platforms, so you have a train come in onto one platform. Then as the passengers are alighting and start to pull off, you'll have the train pull into the other platform. So you need those two platform faces to achieve that trains per hour. We've also dropped the line speed. So at the moment here, the line speed is roughly 100 miles an hour. We're dropping it down to 60 on the mains because we're trying to achieve that sort of metro style railway with every train stopping here and 22 trains per hour. So this is a journey time disbenefit for Great Western Railway trains travelling from the west of England into London. I think in the region of sort of 4.5 minutes. So there is a disbenefit. Everything's a trade-off, and then you've got that increased connectivity to Elizabeth Line. To the west, you've got a train facing crossover, and you'll see on the same, you've got that on the relief line side. The reason being, if there was an all-line block of Paddington, either due to enhancements, Paddington is in need of a remodel, or you have the occasional sort of performance incidents, dewirements, etc. we've had over the last few years, this station should cater to 12 trains per hour on the mains, 12 trains per hour on the reliefs turning back to the west, so that it enables those significant engineering works or performance recoveries to take place with a reliable and fit-for-purpose terminus station. So if you cast your mind back to sort of King's Cross several years ago, and they had Finsbury Park trying to operate that as a terminus, all the negative press, you know, hopefully if we create something that is thought about in that and requirements, then we won't have any of those negatives. On the relief line side, we're trying to achieve 24 trains an hour. When I say trying, that's our remit and that's what we've modelled and we can achieve. 24 trains an hour from the Elizabeth Line central operating section, so from Abbey Wood, Stratford, etc. in the east. 24 trains an hour come to Old Oak Common, of which 12 then continue off to the west. Acton Main Line's the next stop, heading off towards Reading. But 12 trains per hour turn back. So in order to achieve 12 trains per hour turning back, we've got 3 turn back lines. So in the peak, you basically have through trains on the up relief, down relief, either side on the outer 2 platforms, and the inner 2 platforms are used for your turn back services. Now, the need for all of this S&C that's here to the west of the station is to ensure that every platform on the relief line side can reach every turn back and both the through ones, and vice versa, so that in an up and down direction. So that enables us to cater for our off-peak timetable, which we'll talk about in a second, but also cater for performance recovery, perturbation, infrastructure failures, trains, passenger incidents, etc. Because 24 trains an hour is a big ask, and this is a highly critical railway for Network Rail's reputation to maintain the Elizabeth Line service. In the off-peak, it switches up a bit, and it's not through and turn back lines. It's sort of mixed up because we've got to enable ECS moves, empty coaching stock moves, because you've got Crossrail depot here. And during the off-peak times, the trains have got to exit out of service to be maintained and cleaned and enter into service from there. And you've also, in the early morning, you've got freight trains that also go down to Paddington New Yard. There's a freight terminal at Paddington. So yes, you've got these depot connections here to enable the trains to be maintained in the Crossrail depot, and you've got two of them, and it enables parallel moves to again maintain that flexibility. Other things to talk about is these two bridges here, the Central Line underbridge and the Old Oak Common Lane underbridge, will actually stay only about half of the width shown here. So another part of the project is actually reconstructing and widening these two bridges significantly to cater for the new rail systems layout. The relief line speed also drops to 50 miles an hour. I think that's a good summary of the layout. Okay, the next one. So what's happened so far? So I mentioned decommissioning depots. So the Great Western Railway depot was built in 1906, taken out of use finally in 2018, and then the Hex depot, which is in purple, was taken out of use in 2021. So those works were delivered by the Southern Rail Systems Alliance successfully, and now all of that land is handed over to the station construction team, who are now busy. For any of you who travel on the Great Western, if you look out of your left window about the 3 mile post, you will see lots of tower cranes, lots of activity going on. We also did some electricity diversions. So you've got, we used to be a feeder station for Great Western Main Line for the attraction power, but also a HV ring that supplied the depot and supplied, points heating and line side equipment. All of that needed to be cleared again to make way for the handover to High Speed 2 and their contractor for the major civils works. So all of that work is done. What I haven't got here is that we're also in the midst of delivering what we've called Early Works Package A. So this is a series of, I say minor, but they are reasonably significant infrastructure interventions to move assets out of the way of the High Speed 2 station build, or to construct certain aspects of the final scheme earlier in order to de-risk our programme. So I've got some photos at the end, but there are live works going on, modifying OLE, modifying some of the structures and drainage in the area. Okay. So constraints. So I want to talk a little bit about the constraints of the project, because delivering any project is difficult, and your staging, your design somewhat reflects the constraints that you've got. And one of our big constraints is access. So we're in the Thames Valley, which is hard to get access in. And as I said, we're constrained by the Crossrail depot and the North Pole depot. They're both required to be open and operable as much as they can, because if you shut the Crossrail depot for more than, I think it's sort of 2 days, the service starts to plummet. They do not have a comparable maintenance depot on the east side of London, so this is their only rolling stock depot. Similarly, North Pole depot is the main and major maintenance facility for the Class 800s. So again, as soon as you shut that for more than a few days, it starts to be a problem for GWR to actually run a train service. So to build this new station, you run the risk of cutting off and impacting a much wider network due to the constraints of the depots either side of you. Access points are also a big problem. On the relief line side, we're okay, but on the main line side, you've got an access point down here, 1 mile 73 chain, Barby Road, which goes through North Pole depot, and you need to take an isolation of North Pole depot in order to use it, which then means you can only use it certain times because of the need to maintain rolling stock in and out of it. And then there isn't another access point until you get to Jacob's Ladder, which is 5 miles away, 6 mile 63 chain, which is quite small. It's in Waitrose car park, and Waitrose obviously are interested in making sure that their customers, etc., are happy. They're not necessarily interested in somebody parking a load of mutes and RRVs and steelwork in their car park on a Sunday or a Saturday night. So we identified the need basically for another access point in this area, one, to build the project, but two, to maintain it afterwards, because at the moment the maintainer is cancelling renewals in this area because there is no access. So we are currently about to submit a Transport and Works Act order to compulsory purchase Jewson's Builders Merchants here. That's been sort of a long time coming, and that would enable us then to build the job efficiently, essentially, and with the minimal access. You've got other options of trying to come in through North Pole, but generally the operational impact from North Pole I've touched on is significant. Okay, go to the next one. It's a bit about the staging, and I appreciate it's quite small, so I'll try and narrate it. Essentially, how it is today, you've got your 4 tracks of plain line on the Great Western Main Line. The BBVS, the station constructor, and they're also rebuilding the bridges that I mentioned, build everything they can north of the railway. So outside the railway corridor, they will have built 6 platforms, they will have built overbridges, they will have built the new underbridges, they will build as much as they can, all the glazing, etc. In the meantime, we will build as much of the rail systems as we can north of the existing high street environment. And lots of that will be done by road delivery, because then we're sort of separating ourselves from the operational railway. Then, at Christmas 2026, we then take the mains and reliefs through this new alignment. So we use temporary sloughs and temporary layouts, utilise as much of the final as we can, but there will be some temporary alignments to go through the North Station, which frees up the south of the site. As you can see here, this is what it looked like after Christmas 2026. You've now got this space free to the south, which enables the station team to build the final 2 platforms, finish their final bits of the bridge reconstruction and the overbridges. The challenge to that is that it's rail locked, so you're going to have the Great Western Main Line to the north of you and North Pole Depot to the south. So we spent quite a bit of time negotiating with North Pole Depot, and we're now on the cusp of agreeing a road route into that to enable it to be built, because previous to that, the options were trying to build a new station through possessions, bringing materials over these bridges, utilising all-line wraps. None of it really particularly workable, but that was the only option available without negotiating an agreement with North Pole Depot. And that agreement had to go right the way up to sort of DFT, because DFT owned that contractual relationship with the depot. So once they build the new platforms, it's the same principle. We build as much of the rail systems as we can offline, outside of the operational railway. The reason being, to cut down on possessions and the access to the public. And in Christmas 2028, we would then connect up the layout, and then we've got a few stages afterwards to then sort of take out some of these temporary staging and implement the final. So from what you've said there's 2 big stages, Christmas 26 and Christmas 28, and these are significant. Christmas 28, I believe, is currently looking at an 18-day all-line block, okay, which is phenomenal. So we're hoping to reduce that, and it's obviously still in negotiation with network change, etc. So we've got projects to mitigate that. We're looking at diverting trains to other London termini, such as Waterloo, and we're also looking at enhancing the capability of Ealing Broadway to act as a terminus, much like, as I mentioned, Finsbury Park, but hopefully without all the bad press, to act as a terminus for Great Western Railway to interchange onto the Central Line from there. So that's ongoing, and we obviously try and make it as efficient as we can. If we go to the next slide, I think a little bit of why we end up in these massive Big Bang Christmases. ETCS. So currently there's a project to create an ETCS level 2 overlay. So this is a signalling system that, so because it's an overlay, you've got your conventional signalling system. You've also got an overlay of a digital in-cab signalling system, which requires all these new systems with the RBC radio block center, the GSMR communication to it, and the beliefs on the track side, and all of the infrastructure data and software that goes with it. We would be the first major, maybe the first full stop, remodelling of a railway that is an ETCS level 2 overlay. So that's the first, and we are currently allowing 2 years between these changes, because we do not have confidence that the signalling suppliers can turn around these ETCS changes in a short period of time, 2 years. So this is a major constraint that we haven't worked for. You know, we're used to dealing with interlock and data changes. They're in matter of months, but ETCS is a matter of years. So that drives us, if we want to open in that 2029 to 2033 window, that only gives us a handful of actual infrastructure changes we can make to the network. And then we've got to filter those around, you know, the major civils construction program, which again is measured in years, to build the parts of the station. So we're pushed into condensing the access down. The original staging had more stages, sort of spread every year, and even some mid-year stages to try and reduce the access footprint. But in order to meet the opening date, it's being compressed into these mega blockades. And that's what drives us towards, Christmas, really. The other aspect is summer holidays, and any holidays. Great Western Railway and the route doesn't like access during the summer holidays, because that's a big part of their business case, especially post-COVID. Leisure travel for GWR is massive. So when you look at our access footprint, you know, I've seen diagrams where it's been colour-coded, and sort of 2/3 of the year is very little access, if any, and then we just compressed into the sort of winter timetable to try and minimise the impact upon the passengers and the revenue. But obviously make those parts of the year quite tough for the passenger. Wagon requirements, again, when we're pushing, so it's a little bit out of date with the dates at the bottom, but the wagon requirements then to build these major stages in terms of locos, drivers, wagons, etc., is a massive draw. We exceed Western's allocation of wagons, so we need to draw down nationally, which then means it needs to be integrated at a national level with all the other projects that are going on within the country. And that's sort of a scale that when you get pushed into these measure blockades, it really needs to have the national significance and national backing in order to have the sort of internal political weight to get the resources that you need. So we go to the next one. We'll click again. Right, a bit about history. So developer of the layout, we had a GRIP 2 plus stage. So this is a little bit of track engineering in the PY. So Martin Veal was involved in this. Thank you, Martin. So there's multiple constraints driving the layout. And what we had at GRIP 2 was, again, I went through earlier all of these operational moves we needed to fit in, all of the S&C we need to fit. But you've got a load of hard constraints. So the high-speed 2 hybrid bill, put the station there. We had a little bit of wiggle room. They can't move from there because that is the Royal Assent, and to go back and renegotiate that would take too long and bust the programme. The hybrid bill also laid down this dotted line here, which is a limit of deviation. So the track is not allowed to go outside of that limit. So that's another pinch point there that, again, could not be renegotiated because it's past the high-speed 2 hybrid bill. Down here, you've got the North London Line bridge, which is a 4-track bridge. And in order to sort of widen it out at all, would require significant work to the North London Line at significant expense and couldn't really be justified.
Chris, is it worth pinpointing verbally where it is on the drawing for the people who are online?
Yeah, sorry. Yeah, thank you. So for the people online, I've been pointing at bits and bobs. So the platforms are the right-hand orange arrow. The limit of deviation I was pointing to is the sort of second from left orange arrow. And the North London Line is the far left orange arrow. Thank you, Gilles. So essentially, you're quite constrained. You can see as soon as you come out of the platforms, you introduce S&C, and now we moved on from this layout slightly, but then in order to fit all of the S&C in and maintain a turnback for a future 11-car Class 345, your turnbacks, as you can see, are down here. So from there to there is all train standage. From there to there is S&C, and then you're trying to bring it in to this quite narrow pinch point in the North London Line. So all of these led to quite a few iterations. And if we go to the next slide, this one here had quite a fancy arrangement that NRDD showed of how you might be able to sort of do lots of different options, and they didn't all involve such complex S&C, but you can see the sort of the complexity that we were looking at with the sort of scissors with double slips at 3 ends of it in order to try and achieve all those constraints. So that's where we ended up with GRIP 2 Plus. And the point of GRIP 2 Plus was I said there was a little wiggle room in the station. Essentially, it had 50 metres it could slide either way. The best for the station design was to have it 50 metres further west, but 50 metres further west resulted in this. And consultation with asset managers and maintenance said, if that's not a must-have option, we're not having it. You need to try and push the station to its furthest east limits and give us something without these complex double slips. And that was what we did then. We fixed the station at the further east limits. Go to the next slide. So NRDD handed over. We then went out to tender for rail systems, what used to be Group 3, Group 4, but your option selection and outline design. And Arcadis won that. So Arcadis completed the Group 3-4. At Group 3, they looked at different iterations, so now the platforms were fixed. They looked at how to, the main focus was on this turn back S&C, because a lot of the big picture options were already developed for us. It was about how can we make this as reliable for Elizabeth Line services and achieve all the operational requirements. So that led to the layout that I ran through earlier. We adopted, so most of the layout is NR60 Mark 1 S&C, but the turnback lines are NR56V to give us a little bit more space due to the shorter lead lengths. We have a lot of C switches out there. Ideally, we were aiming to have longer switches for sort of a reduced switch wear, but again, you know, the constraints led us to these shorter switch lengths. And again, to cram it all in, we have some sub 250 meter radius CWR where we come out of the C switches and continue that circular curve out of them in order to achieve the geometries that we're going for. And yet, predominantly concrete through bearers, we have a requirement for no modular, which we can actually achieve fairly easily for most of it because of that high street environment I was talking about, because we have sort of areas to do pre-building of panels. The only ones we're looking at modular are the two crossovers down here. They're built in a cutting, they're built in a procession. So they're looking at being modular plus. I'm assuming everybody knows what modular is, but essentially this is pre-building the S&C into different panels that are bolted together, and the bolt has been a weak point that has been identified over the last 5 years or so. So there's work ongoing to improve that, but one of the sort of fix it for now approaches is to introduce non-bolted through bearers in the middle at its weakest point, and so that's what we'd be doing here. Okay. So next one, just click on again, and I'll do both. Acoustic mitigation. So here's another sort of wireframe of the station. You've got your Great Western Railway tracks here. You can see, obviously, I spoke about there being significant subsurface structures. So you've got a basement down here that has sort of operational control rooms, interview rooms, sort of what do you call them? Sort of faith rooms, and even I think there's even a breastfeeding room in here. And all of those have got decibel limits on the noise, and obviously the vibration is propagating from the high-speed 2 tracks and the Great Western Railway tracks. So we're introducing under sleeper pads a softer specification to try and mitigate that vibration noise within the building. We also have airborne noise. The high-speed 2 hybrid build sets some quite strict requirements, as you can imagine, on airborne noise. So this is roughly where the upper leaf will be in the future, and you've got houses that are very close to us. So in our requirements, we've got acoustic barriers being implemented to try and mitigate the noise upon our line side neighbours, and also, you know, sort of gauge face lubrication, top rail friction modification as well. Okay. All right, over to you, Rakesh.
Thanks, Chris. I think Chris touched on most of the operational requirements for the station itself, and so on the back of that, the ENP and OLE side of it mostly covered. So OLE, we've got about 33 wire runs throughout the area, about 39 switches being included, plenty of both the existing ATF is being routed, ATF, the auto transformer feeder route, is being routed around the station to be compliant to the EMC directives and the requirements of the route, which is trying to avoid running it through platform inverts, etc. We've got 2 new DNOs being built. The FSP, there's a new FSP being put in there, which supplies power supplies to the signaling and the aspect of it. Apart from that, we're also doing an upgrade to the existing 6.6 kV ring, which Chris touched earlier. So modification of existing DNO substations around there, and also upgrade to substation S, which sits right here. There is also a new auto transformer site being put, which is kind of T-fed from Kensal Green. So existing supply to the hex depot was being given through a pallet of the Kensal Green, which is being moved over. So that basically, we run a feeding all the way up to the older commons ATS, which will sit over there, which is towards the northeast end of the station area, and that will in turn supply the traction power. One of the first of a kind thing that's being done is this particular feeder station will act as a auto transformer site and auto transformer feeder station as well, with IEC 61850 compliant wrap system in place. Yeah, next slide, please. So as Chris explained earlier, the site is basically the entire station footprint is divided into various sites as lettered down there, and each of these sites are handed over to the rail systems team over the period of time. So essentially, whenever this gets handed over to us, we can then carry out installing the rail systems assets. So going on to that, so pretty much everything towards the north would be built around the 2026 time, and the rail systems would be installed in that area. And then once the southern end of the footprint is available, then we build the mains, the alignment for the mains. That's sort of how it's going to be staged out. Next slide. Just an overview of all the wire runs that is going to be put in there. As I explained, about 33 wire runs. There's a lot of it's going to be 33 wire runs as a final alignment essentially, but for 2026 we would when we wire the northern side of the station, that would be a temporary sort of setup. Then once we move it, once we commission the final alignment, it's going to be all pulled down and then built again, because so there was some efficiency like assessment done around whether we can effectively move around these wire runs, but it's not quite possible because of various operational and practical implications. So it is a massive piece of work that's eventually going to be undertaken. Next, please. This slide basically shows what the proposed sectioning arrangement would be in the entire area, and also shows all the switches that will be installed. There are about 39 switches. A third of that is two-position switches, but most of that is essentially three-position switches. And they're all motorized and shall be compliant to the existing route requirement, which is for it to be able to apply safer, faster isolations, which is remotely controlling all the switches from the ECR terminals. So this involves a lot of the SCADA updates and LV supplies, which is then supplied through various LCCs or line side control cubicles, which are installed throughout the footprint of the station. Over the north, like over just about just in the middle of the slide, you can see the feed coming in from the older common site, which is in turn, as I mentioned earlier, it's T-fed from the Kensal Green auto transformer site. There are some additional works that are undertaken towards the eastern end of the station footprint. So there are sections there which are running all the way from Ladbroke Grove all the way to the existing site, which means in order to install any assets towards the eastern end of the station, we need to carry out isolations which run all the way up to Ladbroke Grove. So the project has identified some efficiencies where we could shorten those sections in order to take isolations effectively, which would then enable the maintainer also to access these sites without having to take long and much more impactful disruptive accesses. This is there. So, next slide. Just a picture of the site where the ATFS is eventually going to sit. As I mentioned earlier, so the power supply to the HEX site was, and the depot, HEX depot, which was previously there, now decommissioned, was being supplied from Kensal Green. Now that is going to be, those pallets are going to be used to feed the older common site as well. There are plenty of existing cable routes which will need to be scaled in order to account for the cable sizing, etc. But largely that is essentially what it is. Slide. This slide shows the overall sort of constraints, site constraints for running the overlay in the station area. Although it is focused on ATF, one of the key constraints we have is the interfacing with the station build. So there is a delta between the development of the rail systems contract or design and the station build. Essentially, the station now is at detailed design. So we are aware where the station is being built to detailed design, whereas the rail systems is not yet started the design. So there is that interface which we very closely need to manage. And as you can see, there is a lot of space constraint there. We've allowed for 3.6 meters as a clearance requirement to any standing surfaces or earth surfaces. So that should allow for plenty of room. We have varied the routing for the ATF or the auto transformer feeder from what it was in the AIP state, where it asked for everything to be run through the inverts, the platform inverts, which was obviously not agreeable to the RAM. Therefore, we have decided to go with the on the main. We will run the ATF through high level, and on the release we'll be running it through the platform 8 CES, which then in turn requires a lot of the EMC compliance and EMC directive. More study needs to be done to assess the impact of that, and appropriate measures need to be taken, which includes providing ferromagnetic shielding and other EMC mitigation. There are also third-party infrastructure along the station footprint, which was mentioned earlier. We got the North Pole Depot, and the station itself, which is towards the right side of the slide. You have the shared accommodation building wall, and since the ATF and the OLE and a lot of the electrical high voltage wires will be running next to it, you have a lot of requirement to assess the EMC emissions and control them. So just some of the constraints from the EMP perspective. As mentioned earlier, as part of the project, we are installing 2 new distribution network operations connections, which at Older Common Lane and Perry Avenue, which would in turn supply the LV supplies for the line side control cubicles in that area, and a lot of the other LV assets like point seating cubicles and junction lighting. Next. Picture of the PSP that would go on site, which would in turn supply some of the functional supply points and supply positions in that area. Next. The SCADA design would be based, the SCADA control is basically to control the MOS switches in the area. It would be in line with the existing architecture for the Great Western Main Line, which would follow the Railcom SCADA system, which is supplied by Siemens, and it would be compliant to the RAT's IEC 61850 spec. That slide just talks about the immunization model that was used. Again, takes into account the entire route and the 50122 model for earthing and bonding. That in turn accounts for all the immunization requirements in that area. ELSA modeling was done in order to identify the short circuit currents routing into and the impact of adding an additional ATFS on the route. As you can see, it shows a 12 kA, which is the highest level of fault for that area, happening closer to where the auto transformer feeder station will be installed. What this means is the OLE needs to be robust enough to withstand that level of fault. Should there be any derailment or any of that, so then in order to avoid such derailments, the OLE would be designed to that. So the overhead line equipment that is being used for the station area is UKMS 100 with 107 contact wire, which has been categorized as able to comply to 12K requirements. Next. Some of the interfacing projects existing on the route. So we have only recently commissioned the converted the traction power system used on that route from classic to auto transformer type. So that project commissioned the 4 new sections of the ATF in that area, and the RATS project, which is changing implementing new protection system in that area by commissioning 2 new substations, is also happening in mid-2023 now. Apart from that, all the switches in that area, the OLE switches, were converted to from manual switches to motorized operations. The final stage of that would be happening at Christmas this year. So these 2 projects are impacting, heavily access dependent, and would impact the station footprint and the activities being carried out in that station footprint. There's also the headspan conversion project, which the route has remitted capital delivery to deliver, which basically is what it says, converting all the headspans in that area to portal type installations. Just a note on asset ownership and how we plan what the maintenance strategy for this would be. The current idea is to hand back the assets in a staged manner. So every time we commission a new asset completely, we hand it back to the maintainer, and then at a later date, if we have to take it back, then we have that hand it back to the capital delivery, and we work on it, and then hand it back again to them, which means we will go through the V&V activities and also going through the compiling HNS files, health and safety files, etc., for each of those stages. We're also carrying out progressive assurance, which is engaging with the routes throughout every delivery aspect of it. Also engaging with the external parties such as the ORR. I think we probably touched on about how we plan to achieve assurance in terms of the ASPA and the NOVO part of it. Probably good. So yeah, that's so the key stages, as Chris touched on before, we got one in 2026, 27, where we commissioned the temporary mains and reliefs. Once that's complete, that would be handed over to the maintainer. And then stage 18, which is for the final alignment in 2029, where the final alignment for the route would be for the station would be commissioned, and there'll be a second handback over there. So that's pretty much it.
Yeah, Gilles, how much time do you think we have left? Just so I know how they have to.
We need to finish about 5 to. If you got time for a question,
fine.
Before that, then that's great.
Yeah. Okay. Good stuff. We'll crack on. So design interfaces. I just thought if you pick actually we'll just go through one at a time. So OLE, Rakesh just touched on design interface here, but I think I originally put this slide in. It's about the interface with the station team. It's nothing too complicated in general from an engineering point of view. We've been building stations and railway systems through them for as long as the railway, but it always throws up challenges every time, even though it's nothing sort of out of the ordinary, etc. There's always challenges. So OLE, there's quite a bit of discussion about the height of the overbridges. So we've got overbridges there. Again, the hybrid bill sets a limit on the top of that, and then there's a very beautiful roof that sits on top of that. And then there's the actual circulation space, and then before you know it, then you're infringing upon the OLE electrical clearances. So we have to fight quite hard at the early stages to set that bridge as high as it could be, so it's at the very top of the limit of deviation that's set out in the hybrid bill, and the track as low as it could be, but the depth of the track, it goes over the top of the high-speed 2 box, so that can't go any lower because the box is also governed by the high-speed 2 hybrid bill. I guess, so if you've ever got involved in very early stages of a project, if you're setting out limits of deviation in the hybrid bill, give yourself as much wiggle room as possible because it will be needed. If we go to the next one, cable management through the station, again difficult because they're building this sort of next month, over the next few months. They're currently piling for the station today. But as Rakesh said, we haven't got our detailed design. So in terms of cable route specifications, the EMC interface, there's a lot of assumptions that go there. And again, trying to be as conservative as we can to give ourselves wiggle room in the future, but without creating something that is, sort of overly conservative. The next one, signalling. Yeah, there's a few signal structures that need to be fixed to the station. Nothing too out of the ordinary there, but the iterations with signal sighting just always create a problem, even though it seems quite a simple thing. Getting the availability of the signal sighting competent staff, getting to sign off on all of these forms is always difficult. And then that ties into, well, the signal sighting puts here and the architect says, oh, but could you move it 5 meters because then it aligns with this advertising space or this cladding system. And so then it results in an endless back and forth trying to optimize it for the passenger at the end of the day when they see the station, and also the operations. Next one. Drainage. So this is, I probably could have put a better diagram up. But what we can see in the very bottom right is a little red bit, and that's the Stamford Brook sewer that we've actually diverted further to the east because it runs through the high-speed 2 box, and it's a Victorian era masonry sewer, and it couldn't be supported, so they've had to divert it with a modern construction, abandon the old one. We're also building, highlighted in yellow, this spur sewer, and all of the network rail track drainage goes into it. The high-speed 2 track drainage from their box, all the surface water from the Great Western Main Line Future Network Rail Station roof, all the surface water from the high-speed 2 station roof, all of the urban realm drainage from the roads and the bus depot, etc. that's there, and provision for future tower blocks to go up and all of the foul water that comes out of the toilet provisions there, plus the foul water from the station. So all of that is going through here, and there's a series of very large attenuation tanks that all of that goes into, because that sewer is Victorian, it's overloaded, in peak rainfalls it surges and overflows, so Thames Water are extremely protective, rightly so, of flows that go into it, and are really pushing us to store as much as we can. SUDS, Sustainable Urban Drainage Systems, is the name of the game. So we've got these huge attenuation tanks, and within the track drainage, we originally had an attenuation tank. We've value engineered it out by sort of having a flow restriction and maximising the storage within the drainage network, so that we don't have to have an additional asset to maintain with all of the carbon and sort of asset management of it, because we're making use of the assets we're putting there to minimise that. Okay. Configuration management. So there's a lot there, but essentially introducing the train service here is also complex in terms of driver training. For each of these major stages, you've got to train all of the Elizabeth Line drivers, all the Great Western Railway drivers, all of the Heathrow Express, like now GWR drivers, for all of those configuration states, and the driver training lead-in is sort of 12 months or so, so it's not a quick process. And then you've got to integrate it with other work that are going on the route. So, if there's then work going on out west, say, the driver training for that has got to integrate with the driver training for here. So it's quite a complicated exercise. And then again, the sort of high-speed 2 upgrade from 3 trains per hour initially to 6 to 10 when Euston's operational. And those dates are just subjective dates. Again, it's all integrated at a wider system level. And one thing that's driving, I talked before about the 24 trains per hour for the Elizabeth line, knock-on impact of that, you actually need to buy more train sets because there's more trains going around the network, so you need to get an additional 3 trains, I think it is. And then there's not actually anywhere to store those 3 trains, so then you need to expand or build a new depot. or stabling for those 3 trains. And so we're thinking about what's going to happen in 2028 now, because the lead-in for all of these driver trainings and the additional rolling stock is quite lengthy, quite costly, and yeah, just has to make sure it's absolutely the right thing to do and make sure that it's thoroughly planned so we're ready for the opening date. Go next one, please. Yeah. See, and that's just photos. So we're near the end of the presentation. I thought I'd put some photos in. So this is the North London line that I spoke about as our constraint at the far west of the job, because it was a narrow pinch point. There's this masonry wall, and the up relief needs to go through the middle of it, because we need to, as we come out from under the bridge, we need to go north as quickly as possible. So we built a new retaining wall behind it. You can see them piling it here. And if we click to the next one, I messed up, but anyway, same again. Click to the next one. At Christmas, we demolished the old masonry wall in front of it. For the most part, the little stub left there. And we've got this new retaining wall behind it. And so new up relief will come through there with sufficient space for walkways and drainage on the south side. So this is work that we are doing today. You know, these are our enabling works that I mentioned earlier. Click to the next one, please. To facilitate that and to move some of the OLE out of the way of high-speed 2 construction, we've been replacing headspans with portals. We've been moving OLE mass around to make space for the different structures we're doing. I think this is in acting cutting, where we're putting in the portals now to just get a head start on our construction program, so that we can de-risk as much as we can the future works. Next one, please. Then the station side of it. So it's funny, you know, as a rail systems engineer, you don't see the scale of construction work you see on a major civils job. The scale of machinery they've got is something else. So it's good when you look out the office window, it's always a hive of activity, and you see the progress happening day to day. So this is the far west end, that's Old Oak Common Lane there. In the future, the sort of entryway into the station will be up here. Down there, you can sort of see the wall. There'll be a ramp down. Under here, you can sort of see the excavation, and there's these props that are being built to support the sides of this. I think it's sort of 25-metre deep diaphragm wall for the high-speed 2 subsurface box. And there's a series of 10 tower cranes that go up over the life of the project. And one of the problems we're having is access to assemble, disassemble them, because the ideal is you have an all-line block because of the risk of collapse. The other ideal is everything happens during daylight hours, and the other ideal is it takes X many days. And the problem is it's hard to get the access that when the supplier wants it to go and dismantle and erect these cranes. So there's quite a bit of negotiation with tower crane suppliers with our asset protection teams on how we can do that safely whilst minimising the impact of the travelling public. I'll actually go back a bit and just see Wembley in the background there. Anyway, next one. This is the view from beneath. So this is a few months ago now, I think. So you can see these props supporting the walls, and you've got a series of excavators in there, basically, excavating, and then eventually gets taken up, and I'll show you where it goes in a little bit. Next one. Yeah, another nice way you can see sort of the bare bones of it as it's getting there. So yeah, it's going further and further down. What you can see up there is it's got a bucket grab on the telescopic jib, I guess, to then go down, grab, lift back up, and load into dumper trucks. And the dumper trucks take it away. You can see on the right-hand side, very small. There's a fleet of about 10 dumper trucks that whiz up and down that road all day long, taking it to a loading area here, which I'll talk about in a minute. But you can see the scale of the construction work that's going on here. You see, tower cranes, crawler cranes everywhere. It really is a massive, massive job. Next one. Yeah, click again. We won't watch that video now. But this is where that spoil goes. So click on the next one. Basically, we load it to a conveyor. So part of the hybrid bill was, you know, we've got a lot of spoil to get rid of. We don't be whizzing HGVs up and down the local road network. I mean, we are running some HGVs up and down, and the road from Wilson Junction to Old Oak Common, the number of HGVs on it is a lot, and the road has deteriorated massively. The high-speed 2 is sort of constantly patching it up because of the amount of tonnage that's going down it. So the conveyor takes it from that stockpile I showed earlier around the houses to Willesden Euro Terminal, which is on the L&W, to be loaded onto rail freight there. So this conveyor removes, I couldn't give you a number, but a very, very large number of HGVs, which, you know, will have an impact upon safety, pollution, et cetera, et cetera. I think I remember it was something from Crossrail. I remember going to a talk from Crossrail and somebody saying, you know, the amount of vehicles that we're going to put on the roads for Crossrail, by probabilities, we will kill or seriously injure people by that. And so I think when you're looking at the number of HGV moves that you're going to implement as part of a project, you've got to think, okay, it's bad for the environment, but also, statistically, are we going to hurt somebody? And could we do something different to not hurt somebody? Because driving is dangerous, and we've had some road traffic accidents related to our works already. So you've got to try and minimise that as far as you can, balancing everything else that you have to. Bear in mind, earlier I said that we're bringing in stuff by road. It's all a balancing act. That's it. I don't, there's plenty of videos to watch, but I think that will do. Yeah.
Okay,
Great.
brilliant. All right, thank you very much, Chris and Rakesh. So invite people to ask questions. We start in the room. Have any questions in the room?
I mean, this is a huge, brand new infrastructure. Where is everybody going to work from? Who's actually going to control it on an operational level?
So there is a shared operational control room within the station. So you've got a joint sort of high-speed 2 operations, conventional rail operations control room with also station control. You've got welfare facilities and staffing facilities for staff who work in the station. You've got BTP facilities for a certain number of BTP staff to be based there. The drivers who book on and off here, book on and off at the Crossrail depot, and there's a walking route from them to get from there to the station. Maintenance depot-wise, we're not proposing any new maintenance depots locally. You've got sort of sufficient maintenance depots in the vicinity. And then obviously we're linked to, as Rakesh has been saying, we're linked to the ECR room, so we're upgrading the screens and facilities there to manage that.
Yeah.
And Didcot, exactly. And at Thames Valley Signalling Centre, we've actually already introduced a new workstation. So as part of the Axle Counter project, efficiencies, we paid that project to deliver a new workstation for us. So at the moment you've got Paddington and Acton, and we're now going to have a Paddington, Old Oak, Acton, because of the sheer volume of work for the signaller. So I spent quite a bit of time trying to get the operational requirements right. No doubt things will change as we progress and we sort of find our feet with it, but we are constantly consulting with operations. We make quite a lot of allowances to make sure they've got the staff they need. Parking facilities as well. There are some network rail parking facilities at the East End for people like moms, maintenance personnel, etc.
Yeah, so you mentioned that there would be what is effectively an early sort of staging event where you're going to sort of construct the early in one way and later on change it. Is the intention to be sort of reused as much of the early as possible?
Yes, so during the staging exercise that's we've carried out, we have looked at whether we can use the raw materials to the level of, you know, just the contact wire, can we roll it and roll it through. We could have, if the staging was allowing for having those loop lines in place along with the main lines, but the short answer is no, we can't really do it, but we've thought about it and we tried to move it and see if we can actually transfer the wire runs and effectively use it for that. But because of the difference in the timeline between the two staging, it is a little bit difficult to do that. But yes, we've considered doing that.
Is the same true for steelwork?
For the steelworks, we're trying to install as many permanent structures as possible. I think there are not many recovering as such.
We're doing as much as we can. The default position was portals. Let's do these big portals, which create their own problems with installation, but it means that we don't have to have multiple temporary structures. I think changes in staging means we might have one or two sort of STCs, but the portals and TTCs should cater for temporary and final
alignments. a lot of the, just to add to that, a lot of the motorized switches, etc., are being installed and will have their OLE installation set up. So you don't need brownfield access later down the line. Inline access later down the line. So you can do all the works as much as possible in the brownfield site.
Yeah, I took that assumption.
Yeah.
No, it's good because we want to, we've got clear requirements to try and reduce the carbon impact, and steel has a massive embodied carbon in it. So, yeah.
Any questions online?
I can't see any questions online. If anyone online would like to ask questions, could you please raise your hand?
Yeah, Gary?
A couple of early questions. The new AT feeder station, what's that actually for? Why is that needed?
So the feeder station is there. So in case if you're taking any line blocks.
That's over here somewhere, isn't it?
Yeah.
So if you are taking isolations of blocks towards Paddington, or if you're doing enhancements at Paddington, then you can feed it. You can
Got you. Yeah. So it does, you're not cutting off
Exactly.
green then.
Yeah.
Yeah, got you.
We identify.
So you can just basically
Yeah. And
basically feed it.
I noticed you seem to be feeding the feeding connections within the platform limits.
No, so it's towards the platform sits up to here.
Oh, okay.
The turn back.
Right, got you.
It's literally towards the. Should have put a slide and shows exactly where it is. So if you look at the whole scale of the platform, the station area, literally at the northeast corner, we have the ATF sits there along with the wrap. The access, the older common wrap is in the same compound as the ATFS.
Final one for me. I couldn't help noticing on the slide you mentioned poplar lines electrification.
Yes.
Does that mean someone's finally doing it?
About 600 meters of electrification.
Yeah.
Is that definitely going ahead?
No. So I can tell you what's going on.
That's
So
great.
I spoke before about we've got these big blocks we need to try and mitigate the impact on the train service. I spoke before about the fact that cutting off the depots. Okay. So mitigating the train service, we're turning trains back at Ealing Broadway. So on the main lines we go passengers go off Ealing Broadway on the mains, proceed beyond, reverse back over, go down that main, up relief the same. But if you electrify the up Poplar, you can then turn back on the up relief and the up Poplar line. So we've got one business case which says if you electrify 600 metres of the up Poplar, then you can turn back 2 more trains per hour in these all-line block situations, for example. Okay. Next part of the business case is decarbonisation wants to electrify the full Poplar's extent. Okay, but there's not funding for that today. But I said before about the Crossrail train service, and if we have more than a 2-day all-line block, they can't get their trains in and out of that depot for maintenance. So what they can do is you've got your depot here. I appreciate people on the phone can't see, but you've got your Crossrail depot, and they can go to the central operating section out Stratford, etc. But they can't get west of Old Oak Common because there isn't an electrified route to get there. So you could loco haul them around. That would just be silly. If you electrify that, extra 2 kilometres or whatever, they can go around the North London line all the way to Stratford. So actually, you can maintain your class 3, 4, 5 fleet at a reduced level whilst blocking this. So they'll do a Reading to Ealing Broadway shuttle service or whatever, and every so often they'll go around Stratford and then back again through the central operating section. So there's 2 business cases there.
Yeah.
Neither of them funded today. We have a cost in from our supplier that we're going through and trying to review with them, and then it's up to the DFC whether it's
that little link is the only thing stopping electric freight trains from running all the way to Cardiff. So.
From a UK PLC point of view, to me it makes it's absolutely ridiculous because it must have such a good business case, but I guess that's sort of...
It's tied up with all the electrification business cases at the moment, which...
It will happen at some point, right? I think that's a given. But whether it's part of this project or a future project is unknown at the moment because it's all about funding.
Okay, I think we've got a question online.
You might not realise Gary's very keen on FLK and volumes for you. Right, sorry. Mick, James, you've got a question online. Would you like to come off mute and ask your question?
Hi, thank you very much. I have 2, if I'm permitted, please. 2 disparate ones. One, why why on earth are we trying to overlay the ERTMS signalling on top of this project? That just seems to be a recipe for disaster. It is one thing. And the other one was you started with a little teaser that there might potentially be reopening the High Wycombe line for children's services into here. Is that a firm proposal or just a sort of a nice to have thought at the moment?
Right, okay, two very good questions. So ETCS overlay, absolutely right, it creates a headache for us. I'm not going to lie about that, it creates a massive headache. So, history, Great Western Railway introduced automatic train protection, ATP, and that is a sort of safety level above your AWS and your TPWS signalling protection systems elsewhere on the network. So that's what the Class 800s have fitted. The Class 345s do not have ATP equipment. So, if you introduce the Class 345s on the Great Western Railway, you have reduced the safety, and the ORR deemed that unacceptable, even though the safety level is, I've not been involved in it, so there could be more nuance to it, but from an outsider, it's the same as everywhere else on the network. But it's the worsening of the safety. So, to provide an equivalent level of protection to ATP, an ETCS Level 2 overlay is proposed for train protection purposes only. Okay? So, it's around the introduction of the Class 345s, not being compliant with the current signalling system. Therefore, we're introducing the next level of signalling system, and that's why. So it's an ORR-led safety justification. Second question, Wycombe line. So again, there's no funding for it yet. However, we have some sort of GRIP 2 level feasibility study designs for a 2-track connection with a 2-phase platform and what that might look like, and a single line connection to reconnect the Great Western Main Line to the Wycombe line, Chiltern line. I say there's no funding. The DfT has funded the construction of the Old Oak Common Lane underbridge to facilitate that rail alignment. So the DfT has released funding to build an additional single track span bridge and extend the sort of main bridge out by another 10 metres or so to cater for the future alignments. So there's not funding today, but the DfT's put its money where its mouth is, which makes me think there's, a reasonable chance of it happening in the future.
Okay, I think we're out of time now, so I'm going to ask Simon to close the meeting.
Yeah. Thank you very much. That was very informative, guys. If we can just show our appreciation in our usual manner, that would be really.
Right. Thank you, Chris and Rakesh. Really